So for the last part of the regular expressions lesson, we'll dig into regular expressions in Python. And this is adapted from this tutorial here. And as we've seen, regular expression is this sequence of characters that helps you match or find other strings using a specialized syntax in a pattern. So with Python, we have this module RE for regular expression that provides all kinds of support for Perl-like regular expressions. Perl is really if you're doing lots of pattern matching and regular expressions, Perl is kind of the original tool to do that with. So a lot of what we use with regular expressions comes from there, and that's why with grep and with sed we have this -e option, which gives us all the Perl style syntax. And we'll see these functions match, search, and replace to handle regular expressions. And one of the things that we do is sometimes there can be interesting ways that the regular expression is interpreted using all these different special characters. And so we will typically precede the regular expression with a lowercase r, and this just enforces that the string that the regular expression that we're providing is going to be interpreted exactly as we type it, and it's not going to try to infer any special characters except those characters that are specifically understood by the regular expression machinery. This will again be a little clearer when we see some examples, and again you want to test these things out to make sure everything's working the way you expect. So first of all, we'll import this RE module. So that'll be when we're ready to use it. We've got it imported into our namespace. And so I'm going to go straight to the search function. There's two functions called search and match that are very similar. I'm going to focus on search for now. So what this does is it will search for the first occurrence of a regular expression pattern within a string using optional flags. So this is the syntax. So we type re.search, so this is our function. The first argument is a regular expression. The second argument is the string that we're going to search in, and then we have these optional flags. You can just leave this part out if you don't need it, but that's all described here. Basically what this flags thing does is it allows us to provide some different modifiers, and the most common one is re.I for a case insensitive search. So somebody asked about that earlier. There is a way to specify you want to do a case insensitive search in Python using this modifier. I'm going to modify this because previously I covered match first, but the only thing to point out about match, so there's a related function called match, which will only match if the string begins with that regular expression. So it's identical to search, except search will find this regular expression anywhere in that string. Match has to find it only at the beginning. But we can use search to get the same thing as match if we just begin our regular expression with this little caret, which matches the beginning of the line. And also Python works a little differently than some of these other tools we've seen because Python is object-oriented, and so the output of this, it's not so much like sed or Perl where you're changing something in place or you're printing it to output, and it's not like grep where it's a little bit more like grep in that you're matching parts of an expression or lines of of a bigger thing. But in Python, you're saving the output of this match as this matching object or the search object that can then be used later to do things. So if we have this sentence, this string, begin with review and friend. So if you like to dive, you would know this phrase. So this is what we're going to search, and so we're going to type re.search and then open parentheses. Open parentheses, and then this is our regular expression. So we're going to use this R before the string to say, yes, this is exactly how I want the string to be interpreted. And so this is now going to be our regular expression here. And so we're going to match a W followed by a lowercase a to z any number of times. And we're going to search for that expression in X, which is the sentence here. So the output of this is not a string or anything. It's this match object. And what this is telling us is that this word with is the part of the string that we matched, and it has these coordinates within the string. So it's important just to see that this is the output that you get from just running this command by itself. But if we save that as something, or and then use this group attribute, or if we simply add that after the expression, group will have the thing that matched. That will be an attribute of this object. So another way we can write this is this. And you can see these are all of the different options we have for this object that match. There's a lot of powerful functionality here. So it's very different from some of these other programming languages, but once you get used to it, there are some advantages. So this would be the identical thing. We're just storing this match object as a variable, and then calling the group function from within that. So if we use this match function instead of the search function, you can see that it doesn't generate anything. When we execute it, there's no match found, so nothing is returned. So if we had search for begin instead, which is the first word in that string, then it does find it, because match has to match the beginning of the expression. However, if we'd wanted to just use search, we could have preceded our regular expression with begin, and it is forced to find it at the beginning. Another good example would be here. So if we had done this with, it doesn't match. Whereas if we remove it, then it does. So you can play around with this and get a little more comfortable, but that's the basic example here. So we'll see a different example here now. So here we have some numbers and letters in a string. So it just says 3.8 liters in 1 gallon, and these two words are capitalized. And then these numbers, this one is a a decimal or a float, and this is an integer. And we're going to do a search command, same as before, and our regular expression is this. So what this is saying is we're going to match in parentheses, which again does two things. It can be used as a group to add like a multiplier or a alternate bar, but it can also be used to group the matching objects and use them later. So instead of using like a $ in Perl or a backslash followed by a number, we didn't really cover that, but in Python you have you're storing these things in the group objects. So here we're matching a period or a numeral from 0 through 9 any number of times, and that whole thing is going to be stored as a group or as a part of our one of our groups. And then we have a space, and then leaders in space, and then we have something similar. We have a period 0 through 9 any number of times. So either of these expressions could match a floating point or an integer actually. And we've written liters and gallon in lowercase, but we're going to add this option, this flag re.I, which has a special meaning. That's how we tell the program that we want to be case insensitive. So it'll match upper or lowercase as long as it's the same letter. And then we're going to this middle part here is the line. So we're going to search that line. So this is our expression, what we're going to search, and then the option. And so we've stored this whole thing as this thing called search obj. And so if we type that expression, or type that variable, and then dot groups, it will print out a tuple of all of the matching groups. So we have this part here in parentheses and this part here, which this part here matched 3.8, and this part here matched 1. And then group, the nomenclature here is a little weird, but group is just matching the whole expression that matched. So this whole regular expression matched, so this is the thing that matched up here. Another way we can, this is just making a little if-else statement, but we're saying if the search object exists, meaning it found something, we're going to do this, otherwise say nothing found. So it did match, so we're going to get the group, and then this groups function takes an argument. So we can either say 1 or 2, which would match the first or the second item. I see. Got that mixed up. Okay, so groups gives us everything. Group with no arguments gives us the whole string, and then group with 1 or 2 gives us just the part that matched. We can also get that same functionality. Since this is a tuple, we can always use this bracket notation at the end of it to get out just the part that we want. So as you can see, it's a powerful tool, but it takes a little getting used to. Even I have to look things up sometimes because I'm so used to the way Perl handles things. But you'll get the hang of it. So this is all for matching. Search and match, remember, they're basically doing the same thing. there's another function called sub, which is really useful. This will substitute for a given pattern. It will replace it with another string, and this string here is the actual thing that we're matching. And then max is an option to say how many times we're going to do that. So in this example, we're going to have a phone number, and then a space, and then a hash sign, and then another space, and then some text. Basically, you can think of this as maybe like a comment or something. So let's say that we want to remove that comment. So what we're going to do is we're going to say for this expression, or this string phone, we're going to run this command re.sub, and then in the regular expression is going to match a pound sign followed by any character, any non-new line characters, any number of times, all the way to the end of the line. So that's the $sign here. And it's going to replace that whole thing with an empty string, and then it's going to do that on this string phone. And then we're going to store that as num, and we're going to print the value of num. So you can see that it's removed from here to the end, so we have what's left is this number, but we have this white space here. So if we really wanted to get rid of that white space, we could do num.strip, and we'd have to save that as itself, but that gives us the value. And if we wanted to remove anything other than digits, we could do re sub backslash capital D, so this is any non-digit. We're going to replace that with an empty string. And because we're not specifying max, it's going to just do it as many times as it can. So it's going to remove everything except for these digit characters.